Next, we have to pick the tool that we're going to use and define its parameters, how fast it's going to go. So eventually, there may be a tool library of tools and materials to choose from with ready-made settings, but just to be difficult and thorough and rigorous, you have to do it yourself every time. Fortunately, it's pretty easy. So in the tool window, edit, create, select tool. So what tool do you want to use? Well, you should have an idea of that when you start envisioning the cut and have picked your material. There are all kinds of tools. There are flat tools with a spiral flute. There are ball nose tools. There are pointy tools, also called a V-bit, which carve very fine details. And then there are things that are not CNC tools. Please do not put these in the CNC machine. The difference between a flat and a round tool is that round tools are generally better at doing three-dimensional contouring surfaces, topography. Flat tools are better at just cutting things out and also cutting sharp-edged details into things when you need them. For this and for most plywood cutting operations at a smaller scale, we're going to use a 1/4-inch flat bit. There are different types of 1/4-inch flat bits, but that doesn't matter after this point in RhinoCam. So pick your bit, flat. The only parameter here that you have to change is that diameter of the bit. And then name it something that you're going to remember and not get confused with other bits if you're using multiple bits in your operations, in your job. Save this new tool. OK. Feeds and speeds. So this is a complicated topic that has its own video that you can click to later if you're interested. But it's a little bit confusing, the terminology. What feed means is the feed rate of your bit plowing through material, so how fast it's moving through space. And speed refers to the spindle speed, which is the twisting speed of the bit. The two are related. They have to be sort of dialed in together to get a good cut. If you imagine the bit is spinning very rapidly as it moves through material, so it has to claw out a little bit every time. Fortunately for you, on the wall behind us in the shop is a handy reference that for sort of everyday feeds and speeds that we use for different bits and materials. Feel free to reference these when you're unsure. Ask shop monitors, ask me. Softer materials like woods and foams are much more forgiving with your feeds and speeds, but it's important to have them set correctly. So the speed is easy. It's always going to be 12,000. That is the speed, the spindle speed that we run our machines at, and there's sort of a reason for that that relates to the power of the machine. The feed rates have these 6 different parameters just to tell it how fast to go through the material. And what those parameters are, if you look at this little diagram, is breaking down all the little different components of it moving through a material. So there's a separate component for its plunge down, and there's 2 little separate components for its approaches, and then there's a cut speed, which is 99.9% of what you're going to be doing, so it's the important one. For plywood and a 1/4-inch bit, I have listed 240 inches a minute cut speed, so feel comfortable using that for all the cut speeds. Jump cut, it strikes me that I just said cut speeds, which is why I mentioned that the terminology is ambiguous. Cut speeds is the same thing as feed rates. Spindle speed is always called spindle speed. You'll hear their words go back and forth. All you need to know is that that spindle speed is always 12,000. The cut speeds, feed rates, whatever you want to call them, are the ones that change for every cut.